Okay, so welcome back to another exercise that we'll do with top amplifiers. Okay, so let's get started because we don't really need that much of an introduction, to be honest. Okay, let's get our two pens and let's mark what we know. So we know there's no current going through here or here, and we also know at this node it's V1 and at this node is V1. But remember that there are currents as well. For example, we already know that it's a current I1 coming in this direction and coming out of that direction, going to the node. But remember, there is not resistance through these two nodes, so theoretically, it's more like practically as well. They can go this way and this way. This one will be I1, and this one will be I2. There are two currents coming through. Okay. No, actually, it's not that way. Sorry, this is confusing. Okay, it's going this way. This has V1 as well, and they are both going towards the ground. I mean, it does make sense if it's here, but remember, there's no current going through here, and it's a current coming out of this direction and current out of this direction, meaning that the only way they can go it's really the ground, you know. Anyway, but the idea is like we need to add those two voltages together to get V1. And let's call this one here I, because it's the combination of I1 and I2. Alright, so then let's see, I would be equal with I1 plus I2, because both of them will go this direction, be down here. Therefore, I would be equal with V1 minus 0 over R. So V1 minus 0 over R. And that will be equal with I1, and I1 is 4 minus V1 over R. 4 minus V1 over R. And I2 plus I2, as it's minus 2V minus V1 over R. Minus 2V minus V1 over R. Okay, therefore we can get rid of the R's because they are the same value. So we are left with only V1 equal with 4 minus V1 minus 2V minus V1. Alright, if you calculate this, let's move the V1s here. So this one will be moved here positive, positive, so that will be 3V1. 3V1, that will be equal with 4 minus 2. And therefore 3V1 would be equal with 2. And let me get out the color. Therefore, because we need to remember this one, V1 will simply be equal with 3 divided by 2, and that will be 0.667 volts. Okay. So we now know the value of V1 here. Actually, I'll write it here as well. It's 0.667 volts. Okay. This is strange. Okay, not because I got the different timer for my phone. I guess I ran out of memory. Anyway. Okay. Now, without we know V1, we can determine the values here at the top. So we can say that 0 minus V1 over R will be equal with V1 minus V out over 2R. Okay. Therefore, let's see, I guess we can, let's just replace with the normal values. So then minus V1, that will be minus 0.667 over R. Now we can get rid of the R's as well. So just leave it like minus 0.667, and then that will be equal with 0.667 minus V out over 2. Okay, therefore minus 0.667 would be equal with 0.335, because to divide by that is 0.35 minus V out over 2. Okay, therefore minus 1.002, we add them together because it will be moved on the negative sign here, which will be equal with minus VO over 2. Therefore, minus VO, that will be equal with minus 2.004, and then therefore we can change the signs to be positive, so VO would be equal with 2.004. okay, oh sorry, it will be equal with 2.004. hopefully you saw that. Anyway, but yeah, this is actually quite simple. Why I wanted to do it is because I want to show that even though we don't know the resistance values, the values for R, we can also calculate what the voltage output would be, even though the only values we know is the voltage inputs. Again, we just don't know what R values are. And you can replace like 2R or R over 2 or R over 3 or 3R or even R squared with any R value, really, as long as you can like make them the same when doing the overall calculation to get rid of them, to cancel them out. Anyway, thank you for watching, and I'll see you in the next exercise. Yes, about my confusion in the last video. Now it showed me like I had like 57 minutes left of recording, and I was like, what was this? And yeah, I posted after that video, and I checked and I saw that apparently when I delete something from the gallery, it doesn't delete forever. It goes into the recycle bin and then disappears after 30 days. And because I record so many videos so often, it was like keeping memory, you know. So I had to like empty that bin. So that's fine. Now I can record back like normal. Anyway, let's see. Okay, this is the next example. This one's the same as the previous one, really, if you look at it. See, but it's a big difference. Instead of here being a normal voltage, it's a actually it's an AC voltage source because it's got the sign 100t. Okay, the 100 is the angular velocity. You should know this if you did the previous exercise with AC theory. Anyway, we don't need to worry too much about this one because, as you know from AC theory, this doesn't really affect anything. Why is that? Well, it's because this is a DC source, so there's only one AC and one DC. Also, all of the components are resistors, and resistors got an angle of 0 degrees, so it doesn't change the angle either, it just stays the same. Basically, what this circuit will do is, let's write in a graph, is the DC will, well actually the DC will pump it down, it won't pump it up. The DC will make it like minus 2 volts down here. Then around this point the AC will start being like 2 volts up and 2 volts down, okay, instead of starting like usual at the 0 point. That's what the DC does, so that's why it doesn't really make much of a difference inside the circuit, meaning that we don't have to use complex numbers for this one, which is very lucky for me. But later we'll get to exercises that have capacitors, inductors, and AC sources, so in the future we will have to use complex numbers, but not right now. Alright, let's get started. So now I'm going through here like usual, and this point will be V prime, and this one will be V prime as well. Okay, now let's see, the both currents will be here at V prime. Okay, it doesn't really have a ground. I guess I could give it a ground. I guess I could give here a ground that doesn't have a wire, so it kind of makes sense that which current it will flow, which direction will flow. So let's keep going. First we need to find the downside here, so let's start with this one. No, let's actually start with the currents. So there will be a current, this one will be I1, this one will be I2, and this one will be I total. But because there's no resistance, it's only ground, then I total will simply be equal with 0, you know. So yeah, okay. I guess it makes sense. I don't know, it's hard to tell, because if the rule says there is no current going through here, that would mean that it's zero current going through both of them. But if I put the ground here, then theoretically it should be like the two currents added together. But there is no resistance, so I guess there's no, I mean, all the current will go through, maybe. I don't know, to be honest. Let's leave it like that. Let's assume that I here will be equal to 0, because that's how I did the calculation for this one. Okay, now minus 2 minus V prime, minus 2 volts minus V prime divided by R plus 2 plus sine 100t, okay, and this one will be taken away by V prime as well over R, and they will be equal with 0. Okay, R is the common here, so we can get rid of it, and so then we'll get minus 2 minus V prime plus 2 plus sine 100t minus V prime, which will be equal to 0. Okay, now let's see, the minus 2 and the 2, they will cancel each other. Okay, so then we'll be left with minus V prime plus sine 100t minus V prime equals 0, and therefore we can move it to the other side, so that will give us 2V prime, then that will be equal with sine 100t. So therefore V prime would be equal with 1 over 2 times sine 100t. Okay, so there you go. We just used normal numbers. We didn't have these complex numbers for this one. Alright, now we need to do the top side, which will be a bit more complicated, but it's fine. So 0 minus V prime, so that would be 0 minus 1 over 2 times sine 100t divided by R, and this one will be V prime minus VO divided by 2R. So then that will be equal with 1 over 2 times sine 100t minus V out all divided by 2R. We can get rid of the r's here. Okay, then therefore minus 1 over 2 sine 100t will be equal with 1 over 2 times sine 100t minus VO over 2. Okay, now we can move this 2, we can multiply this one by 2, so we have the same denominator. Therefore there will be minus, if that will be 2, then I'll move this on, no, that'll be minus 2, then I'll move this on the other side. Yeah, that's good, minus 2 over 2 sine 100t, and that'll be equal with 1 over 2 times sine 100t minus VO. Now we can move this on to the other side, so then therefore minus, then we move it to the other side, that will be 3 over 2 sine 100t. So the sine t will remain the same, and that will be equal with minus VO. Therefore VO, we get rid of the minuses, will be equal with 3 over 2 sine 100t. Okay, I got a bit confused here because in my notes I have it differently. In my notes, because like I did run out this version, in my notes I have something like this, or I used V prime instead. 0 minus V prime over R equal with V prime minus V out over 2R, and then I get rid of the r's because they're the common, but I got minus V prime equal with V prime minus VO over 2. Therefore minus 2 V prime will be equal with V prime minus V out Okay, move it to the other side. Therefore 3v prime will be equal with v out. Therefore v out will be equal with 3v prime, and you can already see that we'll get the same answer for VO, which will be 3 over 2 times sine 100t. Okay, I guess there are two ways to do it. This way was a simpler way, but because I just stopped writing the 1 over 2 times sine 100t for v prime, it didn't make sense to come back to this way, so I just keep calculating in this way. Anyway, so yeah, they are the same answers. I guess they are correct, the calculation is correct. Okay, so I'll see you in the next problem. Okay, here is another simple problem, but it just looks complicated because of the switch. Now, if you have done the exercises, you should already know how to solve this one, because it is very simple. And what we need to do is we calculate the voltage out if the switch is open and if the switch is closed. Okay, so there's no current going through here. This is going to set the ground and it's at the positive pin, so then the outside one will be 0 volts, and here it will be again 0 volts. Alright, now let's calculate for the open switch. Yep, so now we can simply leave it open. If it's open, that means there is no current going through here, so that means that these two resistors are connected in series. And remember that the current going inside this node is the same current as coming outside of this side, okay, from Kirchhoff's current law. Now what we do, it's V in minus 0 over R, so V in minus 0 over R will be equal with 0 minus V out, so 0 minus V out. But remember, now the current goes through both resistors, so it will be 2R divided by 2R. Okay, therefore V in over R is equal with minus V out over 2R. We can get rid of the R's, so then V in would be equal to minus V out over 2. Therefore minus V out will be equal with 2 V in, and then therefore V out will be equal with minus 2 V in. And we can also say that therefore V out over V in will be equal with minus 2, and that will be the gain. Okay, so we found the V out, so V out is equal with 2 minus 2 times V in, and also the gain, we can also write it as gain, it will be equal with minus 2. Now we need to do it for a closed switch, so close switch. Alright, now how do we do when the switch is closed? Well, we can draw it another color here to represent that it's closed. And what will happen to the current? Well, the current won't go anymore through the resistor, it will go, all the current will go through the wire, because the wire has the least resistance, meaning that it will take all the current from it. Okay, so the first half is the same, it will be V in minus 0 over R, but now the second half we have 0 minus V out, 0 minus V out divided by, and as you can see here, there is the resistance R, and now all the current goes through here, and there is no current connected to R, so this one doesn't practically exist anymore, so we just put R, so then this will be R. Okay, therefore we just get rid of the R's, we'll get V in equal with minus V out. Alright, and simply enough we just reverse the sign, so V out will be equal with minus V in, and also we can calculate the gain, will simply be V out over V in equal with minus 1 gain. See, and it makes quite a big difference, and it's also quite useful. Like, let's say if you want to build a circuit and you want to have a switch or a signal that when the signal hits, the gain will be halved. This is a very simple way to do this, you know. I mean, not really half. Let's say you have a signal and the switch stays closed, and when the signal hits, it will open the switch, which will make the gain double, because it will be -2 gain from a -1 gain. If there is no signal going through it, then the gain will stay a constant -1 gain, which will simply be the same value as it comes in. You know, if it comes in 2 volts, it will just come out as -2 volts. Anyway, yeah, this was quite simple, but it is quite useful, because sometimes you want to have switches and signals, and when the signal hits, you want the op-amplifier to give you a different gain. Anyway, this was it for this exercise, and I'll see you in the next one. Okay, now this one got multiple voltage sources, and we don't know the voltage sources, but we do know the resistances, and what we want to know is the value of V out. Now, why is this one different? Well, you have the summing here at the bottom, you have 2 different voltages, and also you have another voltage on the top here. So I think it's called the comparator, isn't it? No, is it the comparator or differentiator when you have voltages going through both pins? But anyway, so let's get started. Now, let's see. Last time I draw a ground here, which I guess it was wrong, because there should be a ground, because that quite changes a bit. So let's leave it to the ground this time. So there'll be a current I1 coming through here, and there'll be a current I2 coming through here as well, and the current here will be equal with I equals 0. Okay, and they will go to this point here, which this one will be V prime, and this V prime will equal with the V prime here. Alright, now let's start calculating. So we start with the downside here, because we need to find V prime before we can calculate it here. So then V2 minus V prime over 2 ohms. Actually, I'll write it here as well. So I1 plus I2 is equal with 0. Okay, so this one was I1. Now we'll do it for I2 plus V3 minus V prime, V3 minus V prime over 8 ohms, and those will be equal to 0. What we can do now is we can multiply this one by 4, and then therefore we'll get the same number here at the bottom, and we'll get something like 4V2 minus 4V prime plus V3 minus V prime, and that will be equal to 0. Okay, therefore the next step will be to simplify it. So we can write it as 4V2 minus 5V prime plus V3, that will be equal to 0. Therefore, let's see here, we need to move the V prime outside of it, because we want to find the V prime. Therefore 5V prime will be equal with 4V2 plus V3, and this is a minus 5V prime, so when you come here it would be a positive V prime. Alright, therefore V prime, what we need to do is now we need to divide it by the 5. V prime will be equal with 4V2 plus V3 divided by 5. Okay, quite simple, and that's the answer for V prime, which we'll use it here as well. Now we can go to the top side and find V out. Okay, so let me separate it here. There you go. So now V1 minus V prime, so V1 minus V prime divided by 2 ohms, the resistance 2 ohms, will be equal with V prime minus VO, V prime minus VO divided by the resistance of 18 ohms, divided by 18 ohms. Okay, now we can multiply this one by 9, so we get the same number again. That will be 9V1 minus 9V prime, and that will be equal to V prime minus V out. Alright, now we need to move the V prime to this side, so then therefore 9V1 minus 10V prime will be equal to minus V out. So now we got the V out separated. Now we need to replace the V prime here with this value here that we have the known values. So then therefore 9v1 minus 10 multiplied by bracket 4v2 plus v3 over 5. Okay, and that will be equal to minus v out. Next, we multiply the 10 by the values here at the top, or we can just do 10 simplified by 5, and then we multiply these values by 2, depending how you like to do it. So then, therefore, let's see here, we multiply this one by 5, so we get the same number. So then that will be 45v1 over 5 minus 40v2 plus 10v3 over 5, and that will be equal to minus v out. Alright, now we can simplify it. We can multiply this one by 5 as well. Actually, let's just go all the way in. You can do it a lot shorter, but I don't know, I guess I'll just do it the long way. Okay, therefore, so then we can say that 45v1 minus 40v2 plus 10v3, that will be equal with minus 5v out. Alright, so that will be the answer. Then we can simplify by 5. So divide by 5. Therefore, 9v1 minus 8v2 plus 2v3, that will be equal to minus v out. And then therefore v out will be equal with, we switch the sign, so v out will be positive, be minus 9v1 plus 8v2 minus 2v3. Okay, now I can show you that it's a simpler way to calculate this. I could just simply divide 5 by 10 and then multiply everything on the top by 2, but I had to show that it doesn't really matter how many steps you take and how cautious you want to be about the calculation, as long as you get the correct value at the end. You know, just take your time doing them, because it's not like it takes ages to calculate. It's not like it takes a long time. And if you like lose yourself on the way, then just reset it, just start it all over again. Because in my notes I have it like this, but while doing these calculations I realized that I could have cut this 10 and this 5 multiplied by 2 on the top here instead, or I could have let down 45 divided by 5, 45 by 5, 10 divided by 5, and get this answer a lot faster for v out or any other things. But as I said, like, I can see this now after I did it like twice. So yeah, I guess if you want to like find a shortcut, you can like do the same calculation twice, and then you see like where you can, what we can do to get it to make it a bit shorter. But it doesn't really matter as long as you get the correct answer. Anyway, this was this exercise, and I'll see you in the next exercise. Okay, now that we are done with the simple circuits, let's go to a little bit more complicated ones. Okay, so I think the first thing you'll notice in this one is that you get 3 OP-amplifiers. And something else that you'll notice is that you got a common resistor here that actually has got 2 junctions as well. So this looks complicated, but it's actually quite simple as long as we do the correct notations. And what do I mean by that? Well, first of all, we need to remember ourselves that there's no current going through here, or here through any of the pins. That's the very first step. Second step is to look at the signs. This sign is the positive, so then this one will be V2, meaning that this node here will also be equal with V2. And this node here is positive as well, so this node will be V1, meaning that this node here will be V1 as well. Okay, other things that we need to understand is that the output here, that one will mark it as VO2, V output 2, and this one here will note as voltage output 1. Alright, now these are some of the steps, and this pin here will be equal with the pin here as well. What should we call it? I guess we should call it voltage output 1 prime, and then this one here will be equal with the same one, so this one will be equal with voltage output 1 prime. Okay, so we noted all the nodes, and remember we did this before we did any calculations. We are just inspecting and looking at the circuit, before we start going inside of it and start calculating and simplifying it. Right, what else do we know? Well, let's see. So there it's there's no current going through here or here, meaning this is something connected to something in series like this. Okay, so we know that in this amplifier the current will go from V2 to VO1 in this direction, because that's the way to find V out. So that'll be the current I2, and we also know the same applies for the amplifier under it. So this one will be I1. Okay, now let's see. We don't really know which one is bigger, if V2 is bigger than V1 or V1 is bigger than V2. So the way we can do it is, let me think. So this is a common between them. I guess we can kind of do like for each one of them. We can do it kind of like superposition. We can assume that through I1 it will come in this direction, as like this resistor here, this up amplifier didn't exist when calculating the voltage output 1, but when calculating the voltage output 2, we can say that the current will go in this direction, in the direction of I2, and as if this one didn't exist. Okay, and if we do so, I guess we will determine which one is the predominant current, because one of these two will be at the end of it a predominant current. There can be two currents going in opposite directions. Okay, this will be about everything. I guess the hardest part to figure out will be the currents coming through here, but remember, usually in amplifiers they tend to like go in these directions, in their own appropriate directions. And I guess if it's got a common resistor like in this one here, just put it, just make it follow one direction, one path. For example, I1 follows this path here, and then I2 follows this path here. Okay, so let's get started. Now let me think. So we can start with I2 here. Okay, so we will start from this node V2. So we can say that V1 minus V2 divided by 2R, it's equal with V2 minus V out, V2 minus V out 2 over R, because there's only one R resistance. Okay, now we can get rid of the R's, and then we'll get something like this: V1 minus V2 over 2, it's equal with V2 minus V out 2. Alright, we can multiply this one by 2 to have the same number. So then therefore V1 minus V2 will be equal with 2V2 minus 2V out 2. Okay, now what we need to do is to separate them. So we need to move this 2V2 to the other side, so that will be a minus 2V2. So V1 minus 3V2, and that will be equal with minus 2V out 2. Alright, now we got the value of this value of minus 2V out 2 separated. So what we can do will be to divide this value by 2 and to reverse the sign as well. So what does that mean? Well, V out 2 as a positive would be equal with minus, because this is a plus, it becomes a minus. Now V1, this was a minus, so it becomes a positive plus 3V2, and then we divide by 2 to get rid of the 2 out of V2. Alright, so V out 2 would simply be equal with that value there. So this one was the first one. Don't worry, we still have a lot to go through, because again there are 3 amplifiers here. Now we calculated for V out 2. Now what we have to do is to calculate it for V out 1. Now we take it from v2 to v1 divided by 2r. So v2 minus v1 divided by 2r, that will be equal with v1 minus v out 1 divided by r. v1 minus v out 1 divided by r. Okay, we get rid of the r's. Therefore v2 minus v1 over r, no, over 2 will be equal with v1 minus v out 1. And then with the same calculations, we'll multiply this one by 2, then it will be v2 minus v1, and that will be equal to v1 minus 2v out 1. Okay, and then therefore v2 minus 3v1, because we move it to the other side, that will be equal with minus 2v out 1. Therefore v out 1 will be equal with minus 2v, minus v2 plus 3v1 all divided by 2. Okay, and therefore this minus v out 1, no, this is the positive one, and let's move this one to be v1 in front of it. Therefore v out 1 will be equal with 3v1 minus v2 over 2. Okay, hopefully you understand the writing. No, basically it's because they have the exact same resistances. Like this one shared the two resistors, the 2R, and they also go through a simple R, meaning that v out 1 would be exactly like v1 2, but instead v1 will be the positive 3v1, and then v2 will become the negative v2. So it's exactly the same, but kind of in reverse. Okay, so this is another value that we need to remember. There you go. Okay, so let me line this one up to like separate it. Now what we need to find next will be v out 1 prime, and to do so we will need v out 1. Okay, so don't worry, we are going to use all the values eventually. To find v out 1 prime, we will need to use v out 1, because v out 1 it will be v out 1 minus v out prime divided by r. So let's calculate this one. Then v out 1 prime will be equal with, and we can do it in two ways. I guess you can use Kirchhoff's current law if you really wish to, but I would recommend to just use the simple voltage divider rule, because it's only one current going through here. So we can just apply the R times v out 1 prime divided by R plus R, and then therefore R times v out 1, oh sorry, it's without the prime, it's just v out 1 divided by 2R, and then therefore v out 1 times R over 2R. Therefore 2v out 1 will be equal with v out 1 prime. If you are wondering from where I got the 2, well, you simplify this one and then you multiply the v out 1 by that one, so it will be v out 1 over 2. Wait, so the r's, they cancel each other, don't they? And then will be 1 over 2. Let me think about this one for a second to make sure. But do they cancel actually? I think they do. No, don't worry, this is the correct way. Anyway, let's keep going. So then v out 2 minus v out 1 prime. So I'm going ahead of myself. I lost my train of thought with this one here. What we want to do next will be to find v out, because now we know v out prime as being 2v out 1. Okay, so there you go, so you can see 2v out prime, v out 1. So then because it's to V out 1, and this has V out 2, we can calculate it. We can do V out 2 minus V out 1 prime divided by R, and that will be equal with V out 1 prime minus V out divided by R. Okay, prime divided by R equal with V out 1 prime minus V out divided by R. We get rid of the R's, and then therefore minus V out 2 minus V out 1 prime now be equal with V out 1 prime minus V out. Therefore V out 2 will be equal with, now we replace it with the 2 V out 1 minus 2 V out 1 prime, and then that will be equal with minus V out. Therefore V out will be equal with minus V out 2 plus, now we replace it with the 2 V out 1 from here, that will be equal with plus 4 V out 1. Okay, therefore V out divided we multiply by 2 will be equal with, now we do the properly, because V out 2 will be equal with minus V out 1 plus 3 V out 2 divided by 2. V out 1 will be equal with 3 V out 1 minus V2 divided by 2. So then V out prime we multiply by 2 because they have the 2 value here, and then that one will be equal with V out 1 minus 3 V2 over 2 plus, and because this one is 4 V out 1, we multiply this one, so 4 times 3 that will be 12, and 4 times minus 1 that will be minus 4, plus 12 V1 minus 4 V2 divided by 2. Therefore 2 V out over 2, yeah, that's it, will be equal with V1 minus 3 V2 over 2 plus 12 V1 minus 4 V2 over 12, no, over 2. Okay, let's keep going under. So now we are on the last steps, because now we just need to find V out. So then therefore we can simply write that as 2 V out will be equal with V1 minus 3 V2 plus 12 V1 minus 4 V2. Therefore we can just do the calculation, so V1 plus 12 V, no, let's write as 2 V out will be equal with V1 plus 12 V2 V1, that will be 13 V1, and then minus 3 V2 minus 4 V1 V4 V2, that will be minus 7 V2. Okay, all right, so the next step will be, therefore let's see here, so we can divide it by 2, so I'll actually write it under here. So then V out will be equal with 13 V1 minus 7 V2 all divided by 2, or I guess if you don't want it in a fraction form and you want like in a numerical form, you can just write it as, or V out will be equal with 2 divided by 13, that will be 6.5 V1, and then 2 divided by 7, that will be minus 3.5 V2. Alright, and that's the answer for it. I know it looks complicated, but again, you can make it, I mean, even I like mixed it up a little bit while I was going through it. You can make it simpler by just notating the nodes and the currents inside the diagram before starting to do the calculations, because at least then you'll have an idea what you're supposed to do. You'll know that you need to know V1, so you can calculate the V1 prime. You'll also know that this one you can apply current divider to it, and you will know that you need to know the value of V out 2 to find the value of V out, even though you know the value of V out prime. Okay, so thank you for watching this video, and we will go to the next one.